Hi guys, welcome to this lesson, and in this video I will discuss systems of equations with no solution and systems of equations with infinitely many solutions. Okay, now recall that in my previous lessons I made videos on systems of equations, how to solve systems of equations using elimination method and substitution method. So let's dive into this one. Now, the first one we will discuss is systems of equations with no solution. Okay, now let's look at the examples here. Please, these questions are often tested on the SAT exam. So this one here, you can see 2x plus y is equal to 5, and 2x plus y is equal to -3. So when looking at this, we are having two same kind of expressions equated to different numbers. So in this system of equations, you don't get any solution. Okay, and also when this equation is plotted on the graph, the both of them are parallel to each other, which means they can never meet. This one will be having a y-intercept of 5. This one also will be having a y-intercept of -3, but they will be parallel to each other and they can never meet. Same thing here. This is 3x minus 2y is equal to 7, and 3x minus 2y again is equal to -4. This one and this one the same. These expressions here the same, but different results, so it can't give us any solution. Now look at this one. This one seems to be different, but they are the same equation. The difference here is that when you divide this second equation here by 2, you get this one. That is to say, 6x divided by 2, you get this. And 4y divided by 2, you get this 2y here. So that is it. Now, in some cases, the student's knowledge is tested on this system of equations without solution. So let's look at this first one here. This is a sample test question. It says solve for B, K, and A if each of the systems of equations below has no solution. Okay. Recall that a system of equation has no solution when two same expressions are equated to different numbers respectively. So in this kind of equation, these here are the same. Okay, that is to say, this one is the same, this one also is the same. So to solve for B here, because we are looking for B in this first one, what we need to do is we look at these coefficients of y here. Okay, so the coefficients of y are complete. That is to say, this is 2 and this is 1. Okay, now since we have 2 here and we have 1 here, so we'll make this expression here and here, we'll make them to be equal. Okay, so by the time we make them equal, then we can now comfortably compare these two, then we get the value of B. So for this one here, we want to make this one and this one equal. So what we'll do is we'll multiply this one by 2. Okay, so let's bring down our bx the way it is. No stress. So bx plus 2y is equal to 6. So 2 times 3x is 6x, okay? Then 2 times 1 here, this is 2y. Then 2 times 5, this is 10, okay? So since this and this are equal, we have made this 2 here equal. So b is equal to 6. Now let's go back to the initial examples. You can see that in every case, this and this are equal, this and this are equal, this equal, this is equal, this equal, this equal. Okay, so that is the target we want to achieve in every kind of equation like that. Then for the second one, we are expected to look for the value of y. Okay, so now look at this. Look at this. So the x coefficients are complete. So we compare. Okay, let's compare. Now, when we compare, we'll see that this is 6, this is 2. So we'll look at the ratio. This is 6 over 2. Okay, 6 over 2 is equal to 3. So what it means is that when we multiply this first equation by 3, we'll make it exactly equal to this one here. So 2x times 3 is 6x, and ky times 3 is 3ky, and 4 times 3 is 12, right? Then this one, we'll bring it down here. This is 6x plus 9y is equal to 10, right? So we can see that this and this are now equal. This and this are also equal. So we have 3k is equal to 9 because the coefficient of y here is 3k. The coefficient of y here also is 9. So since this must be equal to this, that is, this must be equal to this, and also this is equal to this, all the conditions are met. So we say 3k is equal to 9. Therefore, k is equal to 3. Okay, let's go to the next page. For the third one, yeah, we still need to do the same thing here. Now let's compare the coefficients of y which are complete. We are looking for a here. So for the ratio, we have negative 16, okay, divided by negative 8, and this will give us 2, right? So when we multiply this one by 2, we make this equation here equal to this one. So that is what we have on the left hand side. Now we bring down the first one here. This is negative ax minus 16y is equal to 18, and 2 times 6x is 12, okay, 12x minus 2 times this one here is 16y, and this is equal to 2 times this is negative 28. So since this is equal to this, okay, then this must be equal to this. So we have negative a is equal to 12. Therefore, a is equal to negative 12. Okay, so a is equal to negative 12. Now let's look at the second one. Okay, now look at this exercise here. I would like you to solve for b and k in this one. Then please don't forget to put your answer in the comments section, right? Okay, Thank you. So the next one here is systems of equations with infinitely many solutions. So look at this equated to 6, this one equated to 6, this one equated to 6. Now the difference here is that for this second one, if you divide it by 2, divide this by 2, you get this is over 2, over 2, and over 2. You get the first one. So they are the same equation. This one here, the same thing. If you divide this by 2, divide this by 2, divide this by 2, you get this one here. All right. Now, these ones are said to be having infinitely many solutions because there are many values of x and y that you can plug in here to give you same results. For instance, let me use the first equation here. Now, there are many values of x and y that can work here. Let's say if you put x as -2 here and put y as 10 here, you have -4 plus 10 is 6. If you put x is -1 here and y is 8, you still get 6. So if you put 0 and 6, you still get 6. Put 1 and 4, you still get 6. Put 2 and 2, you still get 6. Put 3 and 0, you still get 6. Put 4 and -2, you still get 6, like that. So the values of x that you can input here to get 6 is infinite. Now let's look at this one here. So this one, we're asked to look for m plus n. Okay, it says solve for m plus n, b plus c, and p plus q if each of the systems of equations below has infinitely many solutions. So let's start with this one. Now, okay, this coefficient. Now let's compare this here. So 12 divided by 6 is 2. Okay, that means when we multiply this one by 2, we make this equation equal to this. So we'll now have 2x times 2 is 4x plus 3y times 2 is 6y. 6 times 2 is 12. Then this remains mx plus ny is equal to 12. So m is equals to 4. This must be equal to this. This must be equal to this. N is equal to 6. So therefore m plus n is equal to 10. Then for this one, we are looking for b and c. So let's compare this and this. So we have 25 divided by 10. This is same thing as 5 here is 5, 5 here is 2. So we'll multiply this by 5 over 2. We make the equations equal. Therefore, 4x times 5 over 2, okay, 4 times 5 over 2 is 10x. 10x, that is 4 times 5 over 2. This is 2 times 5 is 10. Plus 6 times 5 over 2. 2 here 1, 2 here 3. 3 times 5 is 15y. Then 10 times 5 over 2 is 25. So this is 25, and we have bx plus cy is equal to 25. The equations are now equal. So b is equal to 10 and c is equal to 15. Okay, so b plus c is equal to 25 because 10 plus 15 is 25. Then for the third question, we have this one here. 6x minus 9y is this, and px minus qy is this. So let's also compare these to 20 divided by 12. We'll have 4 here, 5, 4 here, 3, 5 over 3. So what it means is that when we multiply the first equation by 5 over 3, we get same thing here. So 6 times 5 over 3, 6 times 5 over 3, this is 10, and 9 times 5 over 3, this is 15. Okay, then 12 times 5 over 3, 12 times 5 over 3 is 20. So here we have 6 times 5 over 3 is 10. So we have 10x minus this one is 9 times 5 over 3. Okay, this 15, we have negative minus 15 is equal to 20. This is y. So this is p x minus qy is equal to 20. So this must be equal to this, and this must be equal to this, right? Now we have p is equal to 10, and q is equal to 15. So p plus q is equal to 25. So please do this exercise and put your answer in the comment section below. So if you gained something from this lesson, please do not forget to subscribe, like, and share this video. Thank you so much, and see you in my next class. Goodbye.